Between 100 and 400 million years after the Big Bang, the universe was stuck in a long, quiet pause. The intense heat of the initial expansion had finally cooled enough for loose electrons to latch onto atomic nuclei. This process cleared the primordial fog, leaving empty space totally transparent for the very first time. Yet there was absolutely nothing to see. There were no galaxies, there were no planets, and no stars to emit a single photon of visible light. The cosmos was perfectly clear and completely pitch black. If you were floating in that expanse, you would be surrounded by a thin, cold soup, made almost entirely of neutral hydrogen gas, dusted with a tiny bit of helium. It was a silent, sprawling graveyard of raw material, drifting in the dark and waiting for a spark. That sprawling field of gas wasn't perfectly smooth. Microscopic density variations rippled across the void, creating pockets of thicker gas. Gravity seized on these denser pockets, dragging the raw hydrogen inward into massive, shrinking clouds. This gas was being pulled into immense structures known as dark matter halos. These invisible, massive frameworks acted like cosmic scaffolding, corralling the drifting hydrogen into tighter and tighter spaces. The universe appeared completely dead on the surface, but underneath, gravity was actively engineering the exact physical pressure required to break the dark equilibrium. Inside one of these dark matter halos, a massive cloud of hydrogen is caught in a swirling collapse. Gravity crushes the gas inward toward a central point, packing the atoms into an increasingly microscopic space. As those hydrogen atoms are forced together, they scrape and collide. The friction causes the temperature at the center of the cloud to skyrocket, forming a dense, superheated core known as a protostar. In the modern universe, clouds like this easily radiate away their excess heat using heavier elements like carbon or oxygen, allowing them to fragment into dozens of smaller stars. But this primordial cloud has zero heavy metals to vent the heat. Unable to cool down or break apart, the unbroken mass of hydrogen is forced to swallow more and more material, building up a monstrous, high-pressure state that modern astrophysics can no longer replicate. This process creates what astronomers call population 3 stars, the universe's first generation of massive bodies made exclusively of pristine hydrogen and helium. Because they couldn't shed their heat, these early giants had to accumulate tens to hundreds of times the mass of our own sun before the pressure in their cores was high enough to overcome the natural repulsion of atomic nuclei. The tipping point arrives when the core temperature hits roughly 15 million kelvins. Under that crushing gravitational weight, hydrogen nuclei are violently slammed together and fuse. In that collision, a tiny fraction of the hydrogen's physical mass is destroyed, instantly converted into pure, raw energy. This sudden blast of outward radiation pushes back against the crushing weight of gravity. The inward collapse halts. The cosmic spark catches. Out of absolute darkness, a blinding flash of light erupts into the void. After millions of years of complete blackness, the first star turns on. Burning at a blistering 100,000 kelvins, this star doesn't glow yellow or red. It blazes a fierce electric blue, pumping out staggering amounts of invisible, high-energy ultraviolet radiation. This intense UV light physically attacks the surrounding space. As it hits the fog of neutral hydrogen gas drifting through the universe, the radiation literally rips the electrons right off their atomic nuclei. Astronomers call this the epoch of reionization. It's a cosmic domino effect, where the high-energy light from the first stars clears out the opaque gas left over from the Big Bang. The ignition of these first stars triggered a permanent cosmic phase transition. Their collective radiation lifted the murky fog of the Dark Ages, leaving behind the transparent, starlit cosmos we see today. The immense mass of these population 3 stars guaranteed their lives would be brief. To maintain the outward pressure against their own gravity, they had to consume their hydrogen fuel at a furious rate, burning out in only a few million years. When the fuel ran out, gravity finally won. The massive cores collapsed and detonated in hypernova explosions, unleashing enough heat and pressure to forge the universe's very first heavy elements: carbon, oxygen, and iron. That glowing, metal-rich shrapnel blasted outward, permanently contaminating the pristine hydrogen soup. That debris provided the critical raw material necessary to build every subsequent generation of stars, including our own sun. The heavy elements in your blood and the rocky crust of the Earth itself were forged in those early explosions. The universe's first massive giants had to burn hot and die young in the dark, so that eventually a planet like ours could wake up in the light.
Please subscribe my channel for more informative videos like this.